right, ladies and gentlemen, we're going to take a look at lesson 4.5, and that's the converse of the Pythagorean theorem. If we think back to what converses were, we put the conclusion first, and then the hypothesis second. So we're going to take a look at that Pythagorean theorem converse, and then we're going to use side lengths to classify triangles. So what is the Pythagorean theorem converse? Well, we said if we had a right triangle, then the square of the longest side is equal to the sum of the squares of the other two sides. So now we're going to start with saying, we're going to start by squaring the sides. So if the square of the length of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Before, we always had to start with knowing we had a right triangle. Now we can have any triangle, and we can check it with the Pythagorean theorem. So what that means in symbols is if c squared, c is still going to be the longest side, so c is our longest side, then triangle ABC, if c squared equals a squared plus b squared, then that triangle ABC is a right triangle. So let's take a look at how we can use that. So we want to know, is triangle ABC a right triangle? So we have side lengths of 12, 16, and 20. C is going to represent the length of the longest side. So 20 is my longest side, so that's going to be my C. So I'm going to check and see, do my side lengths make this equation true? So I'm going to start with c squared is equal to a squared plus b squared. So I'm going to fill in c as 20. And I want to know, does that equal 12 squared plus 16 squared? 20 squared is 400. 12 squared is 144. And 16 squared is 256. So we're just doing the squaring there. We then have to simplify each side. Well, the left-hand side is just 400. But the right-hand side, we have to add those two values together. So 144 plus 256 is going to give us 400. So, because it is a true statement, 400 equals 400, it is true that c squared equals a squared plus b squared. So we know that triangle ABC is a right triangle. Move that down the line there. All right, so that's what's going to look like to verify, to prove we have a right triangle. So, in example 1, how do you know which side lengths to use for A, B, and C? Well, I want you guys to do this on your own, and then we will check in class. All right? But I want you to think back, look at example 1. How did we define what C was going to be? All right, let's take a look at our checkpoints. So I'm going to do a couple of these with you to help you out. So if we take a look at the first one, I have to find the length of my longest side. So my longest side is 14, so that's C. So I'm going to have C squared. I want to know if that equals A squared plus B squared. So I have 14 squared is equaling 8 squared plus 11 squared. Realize it doesn't matter which one you call A and which one you call B. You just have to make sure you get the longest side in for C. So 14 squared is 196. 8 squared is 64. 11 squared is 121. So we get 196. Once again, I don't know if they're equal. I've got that little question mark there. 196. 64 plus 121, if we simplify that side, is 185. 196 does not equal 185, so our answer here is no. It does not make a right triangle because the longest side squared do not equal the other two sides squared and added together. Now, number 2, guys, we need to be careful here because they start giving us numbers in radical form, or our side lengths in radical form. And so what we need to do here is to go through and actually figure out what would this decimal value be. So I'm going to take my calculator and I'm going to take the square root of 39. That's approximately 6.3, or 6.2, I should say. we're not going to use that number 6.2. We just needed to have some sort of decimal representation so that I knew whether it was greater than 8 or less than 8. So when we look at this, our longest side here again is 8. So we're going to have 8 squared. I want to know if that equals square root of 39 squared plus 5 squared. So 8 squared is 64. I want to know if that equals, I need to square the square root of 39. Well, I want to show you guys what that looks like when we do that on our calculator. If we're going to our calculator and taking a look at that, when I square that, I'm going to take parentheses, square root of 39, close the parentheses, and then square it. What do we get? 39. And so anytime you square a square root, you end up right back at the number underneath your radical. And that was something we did in Algebra 1. And so hopefully you recognize that. But square root of 39 squared is just 39. And then 5 squared is 29. The left-hand side is still just 64. I need to add the two legs together, the square of the legs. And 39 plus 25 is 64, and they do equal each other. So this is yes. So for C, I want you to do now. So pop, and then we will check in class. All right? Now what we need to do is we want to classify triangles. So we're going to use this Pythagorean theorem. So what happens is sometimes we have c squared equaling a squared plus b squared. And when that happens, we know that we have a right triangle. That's what we just got done proving. But what happens, what can we learn when they're not equal to each other? Well, if c squared is less than, is smaller than a squared plus b squared, then our triangle is acute. And I think of acute triangles as our small measurements, so C is smaller than. So if C is small, and this is our larger number when we get down at the end, then that's the acute. If C is greater than, so my larger value and my smaller value is on the right, then the triangle is obtuse. So you can kind of see it here. As I open up this big obtuse angle here, it creates C, this hypotenuse, to have to be really long. If I close, if I narrow this in and make it a narrow angle, then C gets smaller there. All right, so let's see how we can use that. All right, show that the triangle is acute. So we're going to take the longest side and plug that in. So when we take a look at that, our longest side, on the square root of 35 is almost 6. So I know that this is my longest side. So I'm going to have the square root of 35 squared. And then I'm going to have 5 squared plus 4 squared. I'm going to square each side. So I have 35. I want to know, is that equal to 25 plus 16? So when I look at those, I have 35. On this side, I have 41. 35 is less than 41. That's the final statement we want to make. So you're going to put in either an equal sign or an inequality. So because c squared is less than a squared plus b squared, then the triangle is acute. That's what it's going to mean to classify your triangles. All right, so classify the triangle as acute, right, or obtuse. So once again, we're going to go through, compare the squares of the longest side with the sum of the squares of the two other sides. So my longest side is 8, so that's going to be my c squared. And then I have my shorter two sides, so 6 and 5. This is 64. This is 36 plus 25. 36 plus 25, if I look at that, is 61. 64 is larger than 61. So when we said we had larger than, that was our large triangle, our large angle. So that is our obtuse triangle. All right, we're to the checkpoints. We want to classify the triangles as acute, right, or obtuse. Now, I'm assuming, guys, from a lot of these diagrams that you can see what's going on there. But what I'm going to do is prove for you, we're going to use our formula. So I've got c squared, and then I want to know how that compares to 5 squared plus 2 squared. So that's how we classify our triangles. So 36, I'm going to know, does that equal 25 plus 4? Well, I can see right now it's not going to equal. So I've got 36. On this side, I have 29. 36 is greater than 29. So I can see, because we have the larger c squared, then that means this is an obtuse triangle. And when we look at that angle there, guys, we can see that obtuse angle. So a lot of times we can see that what we're going to get. So the math really helps us verify, because we can't assume that our triangles, that our diagrams are drawn to scale. Let's take a look at number 5. I've got 17 as my longest side, and I want to know how that compares to 15 squared plus 8 squared. 17 squared is 289. 15 squared is 225, and 8 squared is 64. Simplify that right-hand side, so 225 plus 64 is 289. They are equal to each other. So remember, that's what we started off with, guys. The longest side squared is equal to the sum of the squares of the other two sides. So this is our right triangle. Now I want to talk to you about number 6. And number 6, I want you to use a little bit of logic. This is an equilateral triangle. And equilateral means it is equiangular. And we were doing some work yesterday in class with our worksheet, and what we saw is that equiangular triangles are all 60-degree angles. And so I know going into this that this is an acute triangle. But let's look and see how the math compares. Well, there's no long side, so I'm just going to put 7 squared. And I want to see how that compares to 7 squared plus 7 squared. So I think you guys can see where this is going.
Kathy Salinas, if you're in the building, could you report to the guidance office?
All right, ladies and gentlemen, sorry for that interruption. I should have paused more quickly. But 7 squared is 49. And this is 49 plus 49. We can quickly see that 49 does not equal the other side, but 49 is less than 98. And so when we have the smaller c squared, we said that this was an acute triangle. All right? But what we can see, guys, is all of our geometry is blending together here, giving us good multiple ways to prove things. So it's giving us multiple opportunities to prove our statement. We can use this Pythagorean theorem converse to classify our triangles, or we can use what we know about equilateral, equiangular triangles. All right, you guys need to classify those. So how do I do this? Well, you're going to take your largest side. Our largest side is 24. And I want to know, does that equal 24 squared plus 7 squared? So you're going to go through here and do all of these. So you are going to do now, and then we will check in class tomorrow. All right? It's the same exact stuff that we did in 4, 5, and 6, but simply you don't have the diagram to give you the longest side. You have to find the longest side in the data. All right? Ladies and gentlemen, enjoy, finish these up, and bring them to class tomorrow.